Okay, hello everyone, it's Salar and we are in part 46 of our tutorial, a tutorial to writing a real-time operating system. From previous part, I've started to talk about system call structure, and in previous part I got into user space system call, thread create new, okay, a user space system call. But in this part, for the next step, I want to talk about kernel system call. Next step in process of system call in the RTOS. Okay, first step is thread create new. Next step is kernel system call. Another time you can see when you call user space system call, first this function collect all of arguments in a specific data structure, a specific struct. I said each system call has a specific struct and there is a global structure, okay, and this function puts address of a specific structure in this member of global structure in addition of a system call number. After that, call kernel system call by using of this pointer to global system call, okay, pointing to this local variable. This local variable, type of this local variable is a global system call structure. But at this part, in this part, I want to talk about this function kernel system call. You can see kernel system call defined and declared in kernel.h and kernel.c. okay, here is this function in this file kernel.c. okay, but what does this function kernel system call do? Insert its argument. What is its argument? Its argument is a pointer to this structure, okay. Insert global argument to the system call list array, to this array, okay, system call list array. But what's this array? What is this array? Before talking about system call list, I wanted to introduce kernel control block to you. Kernel control block is a data structure like thread control block, okay, and in this data structure you have some information about kernel and RTOS. For example, version of your RTOS, okay, a state of kernel is running, kernel is initialized, or kernel is stopped. In the RTOS type definitions.h, in this header file, you can see kernel control block, this data structure. First, in the at the first member you have the version of your RTOS. After that you have the state. There are three states that defined in this enumeration: kernel initialized, kernel running, and kernel stop. It's not important. Kernel error is not important. Okay, there are three states of the kernel. Okay, after that, tick, the value of tick. By each system tick call, the RTOS increase this value. Okay, each 1 millisecond the RTOS increase this value. After that, current running thread ID, the ID of current running thread, and system call list and system call list index. these two members. I will talk about other members in future parts, okay? System call list and system call list index. Let's to see what are these members. System call list and system call list index. This is an array, okay? And system call list index is index of this array. Index of this array. So I said kernel system call insert its argument global arg to the system call list array. This array, okay? System call list is an array of system call args, global structures, okay? That's been sent to kernel. When you want to send a request to kernel by using a system call, you must put global argument in this array and send this array to the kernel, okay? But the length of this array has been defined here. The length of this array, system call list length is 4, okay? System call length is 4, okay? But how is this variable an array, okay? How is this variable an array, a double pointer? To see that, how can we define an array by using a double pointer? I want to describe that here. I'm gonna be showing you how in this slide, okay? First, you can define an array of integer like here, okay? And in this way, compiler allocate memory to this array. And you know A is a pointer, okay? Pointer to first element of this array. But you can define your array like this way. First, define the pointer to first element and allocate memory to this array by using of malloc 10 integer numbers, okay? In this way you can define an array of integers. But assume you want to define an array of pointers, okay? Here is array of pointers, okay? 10 pointers in this array. But another time you can define your array in this way. First, define pointer to first element at this time is a star star double pointer, okay? Because this value points, because at this time a points to a pointer, okay? Double pointer. Instead of define your array of pointer in this way, you can define in this way. First, here is pointer to an array of pointers and allocate memory in this way. So by using a double pointer variable, you can define an array of pointers, okay? So another time, system call is array of pointers. Which pointers? These pointers. Kernel system call insert these pointers to the system call list array, okay? And here is index of the array. Okay, another time, system call list. system call list will be initialized in kernel initialize function here. Here you can see in kernel initialize function, initialization of kernel system call list, initialization of system call list by using of this function in kernel initialize. Define the array by using of malloc, okay, and initialize this array by null, okay. After kernel initialize, all of elements has null value, have null value, okay. After that, initialize the index by 0. Initialize the index by 0, okay. Initialize system call list. After that, initialize the index by 0. So another time, kernel system call, second step in process of system call structure, insert address of global structures to the system call list by using of this function, but now I wanted to inspect this function. You can see you have an atomic part in this function, started by atomic read, load exclusive, this function called port atomic read 32, and port atomic read 32 is load exclusive, okay. Read, modify, and write by store exclusive. But let's inspect this part here. At the first time I said system call list, here is system call list initialized by null, and index is 0. Index is 0. List is kernel system call list, and kernel index is this index, okay. Kernel index is the kernel control block index, but index here is this function is a local variable, okay. Your index is a global variable. To read the kernel index, in this local variable. But assume thread 1 wants to call a system call. After calling kernel system call wants to write the argument in the system call list. First, read index. Index is 0. If list.index, list.0 here, 0, 1, 2, 3. If list.0 is null, write argument in list.0. Argument, okay. After that, if write is successful, atomic write exclusive store is successful, break this while loop, okay. Break this while loop, read atomic and write atomic, write the argument, the pointer to address of first element in the system call list. Index, okay, by using the index here. But why do we need to have an atomic part in this function? To describe that, let's see a situation and a scenario. Another time, assume that system call list is free, okay, and thread 1 wants to put an argument in this system call. Okay, in thread 1, in body of thread 1, for example, assume in body of this function, okay, you called a system call, okay, in this way. First, read this value, index is 0, okay, check first element. If is null, thread 1 at this time wants to write its argument in this element, but assume at this point you have an context switch, okay, after checking this element, okay, and the RTOS jump to thread 2, okay, and another time in thread 2 you have another system call, okay, you have another system call. Another time in thread 2 kernel system call, read the index, another time index is 0. Check for thread 2, check if list 0, this element is null, write the argument of thread 2 at this argument, at this element, and write argument of thread 2 in this element. But another time, assume after write, another time you have context switch, but in this time context switch in thread 2, okay, context switch in thread 2. Assume another time at this moment 1 millisecond has elapsed, and another time you have a context switch, but after writing this argument in the system call list. Another time RTOS return back to thread 1. Thread 1 has left this function from this point, okay, from this point after checking list.0, okay, and now thread 1 wants to write its argument in index 0, right at this element. So thread 1 cropped thread 2 request and write at this time thread 1 argument, right its argument. You can see thread 2 argument has been cropped, okay. Because of this scenario, you must have an atomic part in the kernel system call, because system call list shared between threads, okay, shared between threads. But another time, let's to see the scenario by using an atomic part. Another time, assume thread 1 wants to write its argument in the system call list. Index is 0, check the index, but you have a context switch from thread 1. Okay, you have a break in the atomic part and jump to thread 2. Thread 2 wants to write its argument, but you have context switch from thread 2 after writing the atomic value. Okay, if RTOS return thread 1 doesn't write its value, because you have a break in atomic part. Okay, doesn't write is unsuccessful. Okay, another time return back to the startup while loop, but another time index is 0, but at this time list 0 is not null, it has a value. Doesn't write this part and write this part. Do index plus plus and write index plus plus in the kernel.index. Another time return to the startup while loop, but at this time kernel index is 1 because of index plus plus, and this value is 1. But at this moment list 1 is null. Okay, this is null, and the operating system write argument of thread 1 in this element, and because write is successful, run break. RTOS runs break. Okay, because of this scenario you must have an atomic part in kernel system call function. Okay, so very good. Let's see running of kernel system call in debug mode. Okay, now I'm in debug mode and here. Okay, let's do run thread create. After jumping to this function, first check arguments. If all of arguments are okay, first check interrupt. You can't call thread create new from interrupt if you are not in interrupt. Put all of arguments in a specific structure. Now in this structure you have thread name, thread function parameter, priority, stack size. Okay, and at this time return value is not important, it's 0. The value is D, it's not important. Okay, so you have all of arguments in this specific structure, and put thread create new system call in global structure and address of specific structure in global structure. Okay, and by using of kernel system call, write this pointer in system call list. Jump to kernel system call. First get kernel system call. Okay, after that you have a atomic read the index to this local variable. Okay, if system call list, if the first element index is 0. Okay, you can see index is 0. If first element is null, write the argument in the kernel system call is but right, and if atomic write is successful, break the while loop. Okay, in future part I will talk about kernel system call request and SVC exception. Okay, because we send all of system call request to the kernel, and kernel runs in supervisor exception, in SVC exception. Okay, in future parts, in next part, I will start talking about SVC, okay, and using SVC to implement system call. So in the process of system call, first collect arguments and call kernel system call. In kernel system call, put the arguments in the system call list by using a kernel system call function. In next part, I will talk about third step. Okay, thank you very much to see me, and see you soon in the next part.